Hi, welcome to video 8.2b, part 1, repeated integration by parts. So, we're now going to repeat the process, and here's an example. So you notice what's a little different about this one is the x squared, and that's going to cause havoc. So, as usual, your choices for dv are either x squared dx or cos x dx. The trig is definitely uglier than the quadratic and easy to integrate. So dv is cos x dx, or you can't see the dx over there, but oh, there it is. And u is the rest of it, which is x squared. So we're going to take the derivative of u, we'll get 2x dx. We will then integrate both sides here, giving us v is the integral of cos x dx, which will be sine x. So the three pieces we need are the u, the v, and the du. So again, I'm writing the formula. Now, this is very important. I have to write down the left side, which is the original thing, all the way down, and you'll see why. So, we have the original question, integral of x squared cos x dx. Here's our formula, uv minus the integral of v du. So I plug everything in. My u is x squared, my v is sine x, my v is sine x, and my du is 2x dx. I'm kind of just placing it. Now, what you'll notice is this is also ugly because it's also, there's nothing else you can do. The substitution won't work. It's very similar to the original one, which was x squared cos x. This is x sine x. So we have to do this one by parts as well. So what happens is I can't use u and v. I've already used them. So what we do is we say u bar and dv bar. Okay, so I'm doing just the red right now. The rest stays the same. That's on the left side. There's my x squared minus sine x. There's my minus, and I'm just going to pull out the 2. So I'm doing this without the 2. I have this x sine x, so I'll let dv. Now this is important. When you're selecting the dv bar, because in the original one, you let the dv equal the trig function part of it. You let the dv equal the trig part. You have got to be consistent, or this will not work. You've got to let the dv bar be the trig part, which you would anyways. So you'll let dv equal sine x dx. You'll let dv bar. You'll let u bar equal x. So du bar is dx. V bar is the integral of sine x dx, which is cos x. So now, instead of uv minus the integral of v du, I have u bar v bar minus the integral of v bar u du bar. So my u bar is negative x. My u bar is x. My v bar is negative cos x. So that's where that negative comes from right here. Then I have minus, and then v bar is negative cos x, and du bar is dx. So what's going to happen is you are going to end up with the following. Now, right now, I did write the left side. I didn't need to, but you'll see in the next one I will. So now I am going to integrate my negative cos x, which would be, I can pull the negative out, becomes positive. Integral of cos x is sine x. Don't forget I have a 2 here that I need to distribute, and there's your final answer. But I want you to start getting used to writing the original equation on the left side, and you'll see why. So this is the repeated integration by parts with a twist. Okay, so obviously nothing else is going to work here. You can't let u equal 2x or cosine 2. You don't have the derivatives. You can't let u equal e to the x. So substitution won't work. Got to do it by parts. Now, again, what should dv be? Well, you might think they're both kind of ugly, but I'm going to go with the trig. You could try with the other, see what happens. So if I let dv equal cosine 2x dx, then the rest of it is the e to the x, so that's my u. Derivative of e to the x is e to the x dx. The integral of cos 2x dx, of course, you would have to introduce the 2, counteract with a half. You'll end up with 1/2 sine 2x. Now, you must write this one down, and this time you really must write it down. So I have uv minus the integral of v du. So I put in my u, which is e to the x, my v, which is 1/2 sine 2x, minus the integral of my v, which is 1/2 sine 2x, times my du, which is e to the x. So what happens is, you'll notice, I now have, if I pull out the 1/2, I now have the integral of e to the x sine 2x. Now notice how similar that is to what we started with, which is e to the x cosine 2x. So that's also going to have to be done by parts. And again, you have to be consistent. Up at the beginning, when you did this, you let dv equal the trig part of it. So you've got to be consistent, and you've got to let dv bar equal the trig part of it, which is sine 2x dx. So that means u bar is the rest of it, which is e to the x. Differentiate, integrate, and now you're going to have u bar v bar minus the integral of v bar du bar. But you still have that original thing on the left. You still have your original uv minus, and then you have this 1/2, and it's this circle, in this green circle thing is all this green stuff. So u bar v bar minus the integral of v bar du bar. At this point, if you don't write the left side, you're going to think you're at a dead end, because you're going to look at the right side and you're going to go, well, I have another e to the x cos 2x, and that's what I started with. That's precisely the point. If I expand over here on the right side, if I distribute, now I'm just distributing the negative 1/2 times negative 1/2 e to the x cosine 2x is 1/4 e to the x cosine 2x. I'm also distributing the negative 1/2 times negative 1 times negative 1/2, which will be negative 1/2, and then I have this integral of e to the x cosine 2x dx. The thing to recognize here is that that integral that you have over here in this red bubble is the same as this integral over here. The only difference is this one has a coefficient of 1 and this one has a coefficient of negative 1/4. So it would be as if you had x on the left equals blah blah minus 1/4 x. You would bring the x's to the same side. So you have one of them plus 1/4 of them, which will give you 1 1/4 or 5/4 of those things. Then I'm left with all the rest of this, which is this 1/2 e to the x sine 2x plus 1/4 e to the x cos 2x. And now I can multiply both sides by 4/5, and lo and behold, by doing that, I find out that the original integral I was given is equal to 4/5 times this expression plus c. So it is a little tricky.